Okay, so the question asks us to find the maxima and the minima of the following functions on these specified domains. So what you want to do in this is you want to really just follow a very step-by-step procedure. You want to find all the critical values. So find critical values. Critical values on the 0, 2. And the way you're going to do that is the first thing you're going to do, the critical values are where, what the value is at the endpoints. So you plug in 0 to the 0 squared minus 0 plus 3. It's going to give you 3. So 0, 3 is a critical value. Then you're going to plug in the endpoint. The endpoint is going to give you 2 to the second squared minus 2 plus 3 is equal to 4, 8. 8 minus 2 is 6, 9, so you get 2, 9. Now, the other critical values are where f prime of x equals 0 on this interval. So if we're going to do that, we're going to solve this. We got to take the derivative. We're going to get 4x minus 1 equals 0. That means 1 4x, and x is equal to 1/4, which is indeed a point on this interval. So what's the other critical value? So far we have these two, and then we're going to get another one. We're going to get 1/4 comma, and then to find its corresponding value, you plug it in here. It's going to take some time. To 1/16, right, when I square, minus 1/4 plus 3. This is 2/16 or 1/8 minus 2/8 plus 8, 16, 24/8, which is going to give me negative 1/8 negative 23/8. So 23/8 is 2 and 7/8, just to compare it to 0, 3, because this might be a minimum. So now this is all your critical values on this interval. You would also want to see where it is that this is undefined, but f prime being 4x minus 1 is defined everywhere. So these are your 3 critical values. Now, if you want to find out where the minimum and the maximum are, it's easy. You just find which one is the smallest and which one is the largest y value. So 3, that's greater than 2 and 2/7. So that means that this is a minimum on this interval. And then the endpoint 2, 9 is a max. And you're done with this first one. Now, to do the next one, you follow the same procedure. You sit here, you find the critical values. Yes, and they've excluded 1 because this function is not defined at that 1. So it's a nice thing that they've excluded it for us, so we don't have to deal with it. So what I do is I differentiate again, or I find out what it is at 3, right? When I plug in 3, I'm going to get 9/8. So it's going to be 9/8. 3, 9/8 is a critical value. And then you don't care for at 1 now anymore, okay? That's not going to be a critical value. It's only at the endpoints of a closed interval. This is a half open, half closed interval, so you don't need to worry about that 1. Now let's see where it is that the derivative equals 0 or is undefined. Let's first see where it equals 0. So I'm going to take the derivative of this. I'm going to use quotient rule. 2x times the bottom function minus the bottom function, the derivative of the bottom function times the top function over the bottom function squared. And I'm going to set it equal to 0. I could do a little bit of simplification here. It's going to be 2x squared minus 2x minus x squared over x minus 1 squared. And I'm going to get that this simplifies to x squared minus 2x over x minus 1 squared. And this equals 0 at 2 different points. It equals 0 when x is equal to 0, which I don't care for because it's not on the domain that I care about. And it equals 0 when x equals 2. If I factor out the top, right, just to show you how I got that, right, this factors like this, and then it gives me the x equals 0 and when x equals 2. Now, when x equals 2, that is actually a critical value. So 2, comma, I plug it into the function 4, 2 minus 1 is that. So it's 2, comma 4 as a value and as a critical point. And, 4 is the y value. Now, where is it that it's undefined? It's undefined, this derivative, when x is 1, but that's not in the interval, so I don't care. What that means is that your max is at this point, and this is your min. And you could even sort of make a different conclusion here. I think that this thing, right, but then, oh wait, did I plug in 3? Oh yeah, okay, so now what's happening from 1? Oh yeah, it's increasing, right? So it's increasing everywhere from 1, not including 1, to 2, this function. And then it reaches its max, and then it decreases to this value over here. But now, does that guarantee that this is the min? Because to me, this could maybe not be the min. So let's see, how could I test that? This is 4, this is 8. Is this indeed a min? Well, let's see what's happening here. Let's get a graph of what's happening here. So 1, 3, and then now I have that 3 and then 2, so there's 2 in between them. And it is true that this is increasing, but now what's happening near 1? So this is near 1, I'm going to get a positive in the top and then a negative in the bottom. But to the left, it's going to be that this is positive. So it's positive or positive. So near 1, this function is coming from positive infinity, which is no good, because then that means that this is a min. And then it goes back down. It continues to decrease. Okay, so let's get further evidence for what's happening here. Let's make good conclusions. So take your time with stuff like this, because it's weird that they isolated this 1 from this interval. So I have it that is 1 to 3 here, and it's the function x squared over x minus 1. And if we look at this function, right, near 1, so here's 1, right? What I get is that as I approach 1 from the left, it's actually spiking down towards negative infinity. So it's like this, because near 1 is like 0.99, so then that makes this bottom part negative. But then this top part is still positive, and this bottom part is very close to 0. So that's why it spikes down towards negative infinity, because it's negative and it's very large. On the other hand, when you go towards 1, but on the positive end, you should see that it's actually spiking up, because then now this is positive, and then this is positive. So then that means that it looks like this. And then it's going to come to 2, and 2 is going to be a min. And then it, according to what I have here, at 3, it's going to go down again. So it's going to look something like this. And then I have that this, the function is neither increasing nor decreasing at 2. So that's nice. That's the whole key here. This is going to be not a local min or max at 2. It's just going to flatten out at that 2 value. Let's make sure. So I'm going to take the derivative, 2x times x minus 1. I'm doing the derivative again, minus the derivative of the top times the bottom. So the derivative the bottom is 1, and then times the top is just that, over the bottom squared again. And now I get that this is the same thing as 2x squared minus 2x minus x squared over x minus 1 squared. This becomes x squared minus 2x over x minus 1 squared. This becomes x times x minus 2 over x minus 1, x minus 1 squared. That's my derivative. I want to check to see what's happening to the left of 2 and to the right of 2 in this instance here. So to the left of 2, what do I get? So to the left of 2, I'm going to have like 1, right? Or let's do 1 and 1/2, right? 1 and 1/2 is positive. This is going to be negative. So the whole top is negative. 1 and 1/2 minus 1 is positive, or the bottom is always positive. So I have that my function is decreasing on this entire interval. The first derivative is negative. Now let's go to like 2.5, right? So 2.5, this is positive. 2.5, this is positive, and then the bottom is positive. So my function is increasing here. So it looks like this, and this is a local min. So it's a good thing I went through this. This is a local min. And then now it increases all the way till 3. So what did I get here when I plugged in 3? Did I plug in 3 wrong? Is that why it's all messed up? 3 is 9/8. I'm saying 3 is 9/2. There we go. And then it's 4.5. You see? So one bit of arithmetic threw off all my logic for this, because I was wondering how this could all happen. So you see now this makes sense, because now this is 4.5. So then this is indeed a min, and everything switches. So just that one bit of arithmetic mistake changed everything on how I do this. So the correct way of doing it would be to say, let's not do that. Let's go back to what I had over here. And then let's now, again, I caught my mistake because it didn't make sense. And then I sat here and I figured it out by taking my time and seeing what's actually happening with the derivative and so forth. So what's a good procedure here? What was it that I should have started with? Again, find critical values. I did that okay the first time, but I messed up in determining the y value for a given critical value. So find critical values. 1. Let's see, where are the critical values? At the endpoints and then at 3. So when I plug in 3, I get 9/2. So it's 3 comma 9/2, which is 3 comma 4.5 for one critical value. The next critical values are where it is that f prime of x equals 0. So that would involve me getting f prime of x, which I got as x squared minus 2x over x minus 1 squared. And I set this equal to 0. This is going to equal to 0 whenever it is that x equals 0 or when x equals 2. So the 0 value I don't care for, because I'm only concerned about in this interval. But the 2 value I am concerned about. So x equals 2 is going to be a critical value. So 2 comma, and I find its corresponding point. 2 is 2 squared 4, and then 2 minus 1, this is 2 comma 4. And then this is the only value that I have in this interval where f prime of x equals 0. If I want to find out what these values are, you can sort of kind of see that now it makes more sense to say that this is, let's say, 1, 2, 3, and then now I have that this is going to be looking as follows. So 3 is going to give me 4.5. That's a height point right here. 2 is going to give me 4. Let's say that's right there. And then 1, it's spiking down from negative infinity, looking like this. And this is indeed a local min. And you can check that that's a local min by seeing how your derivative behaves to the left of 2 and to the right of 2. I found out that the derivative is positive over here. Right, the derivative was positive, so that means that this is going to go down, 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 up over here, and it looks like this one here, and now you have it. Okay,